Hi everyone, back for another video. Today we're going to look at special products, just some shortcuts to handle things when you don't feel like writing out the entire polynomial multiplications. So let's just kind of run through what that looks like. So if we had x plus 3 times x plus 5, we know now that you're just multiplying every term in one bracket by every term in the other bracket. Okay, so you end up with x squared plus 5x plus 3x plus 15. Okay, and then you'd simplify anything that has like terms and get 8x plus 15. Okay, now in some cases you might have special cases where you end up with something like x plus 3 times x plus 3. But I think we're getting ahead of ourselves a little bit here. Let's use something that's a little bit more familiar to us, something that we've been using for a long time. So let's just do some BEDMAS. Okay, so here's something that looks kind of similar. Remember, the x is just standing in for a number. So if you have something that looks like this, right, then anything that we did with this set should be able to do with this set. So keep that in mind in a second. So for now, though, we're just doing BEDMAS. So this is going to be 7 times 7, because we have to do the brackets first, which is going to equal 49. Okay, let's try this a different way now. So I'm just going to write this out again. 4 plus 3 times 4 plus 3. And this time we're going to multiply things out like we did with our polynomial multiplication. And get 4 times 4, which I'm just going to write as 4 squared. And I'm going to get 4 times 3. And I have 3 times 4, but I'm not going to write it out as 3 times 4. I'm going to write it out as 4 times 3. Doesn't matter what order you multiply in. 4 times 3 and 3 times 4 are exactly the same. 3 times 3 is 9. Okay, so I'm going to write it out as 3 squared, though, rather than write it as 9. Now I'm going to do this. I have groups of 3, right? In fact, I have groups of 4 times 3. And how many of them do I have? Well, I have 2. So I have 2. I'm going to use a square bracket here. 4 times 3 plus 3 squared. So now notice it wouldn't have mattered what numbers I would have used here. The 4 that appears here and there. And the 3 that appears here and there. So as long as I have the same numbers in both sets of brackets, then I'm going to get the same pattern. And I'm just going to write this out a little bit differently on the left as well. Not 4 times 3 times 4 times 3, but 4 plus, or sorry, rather than 4 plus 3 times 4 plus 3, I'm going to write 4 plus 3 all squared. That. Now, let's just run a quick check that we still get the same answer. We need to get 49 or else something we did doesn't make sense. So we have 16 plus 2 times 12 plus 9, which is going to equal 16 plus 24 plus 9. This whole thing here is 40, plus 9 is 49. So that looks good. So what we're doing here seems to make sense. It checks out with what we already know this has to equal. And again, we can notice that it doesn't matter that if we used 4 and 3, or 10 and 11, or 15 and negative 5, you'd still get the first thing that's in the bracket here showing up there, and the second thing showing up here and there. And so our quick conclusion is we can replace the numbers with these variables here, indicating that it doesn't matter what A and B are, that this still works. And so we can do an example now using this to allow us to do stuff really quickly. So let's go back to that x plus 3. So if we had x plus 3 squared, then we know we just take the first thing that's in the bracket, and we square it, plus 2 times the first thing times the second thing, so x times 3, and plus this last thing squared, which will give us x squared plus 6x plus 9. Okay, and let's take a look at one that looks more like this. We'll make it a little bit more complicated. Let's have 2x minus 3y all squared. So first thing squared, 2x squared, plus 2 times the first thing, which is 2x, times the second thing, which is 3y, plus the second thing squared. Now you see I made a little mistake. We have a negative here. So because we have a negative, this one here has to be negative. So I'll fix that up because we're using this one now. And so now you're just simplifying. 2x squared is 4x squared. Minus 2 times 2 times 3 is 6 is 12. 12xy. 3y squared is plus 9y squared. Okay. And there's the answer. Okay, now another pattern that you might end up with is instead of having a plus b times a plus b, you have a plus b times a minus b. So we have a switch of sign here. And so now all we're going to do for this one is rather than go back to the numbers and try to explore that, we're going to trust that doing this is the same as doing BEDMAS. It's still going to give us the same answer. And so we're just going to go ahead and do the binomial multiplication. Okay, so a times a gives us a squared. A times minus b gives me minus ab. B times a gives me plus ab. And b times negative b gives me negative b squared. Now notice that these two are the same with opposite sign. So if I have ab and I take away ab, I end up with nothing. So I'm not even going to write it because it's nothing. You don't write nothing. So our conclusion is then that a plus b times a minus b is equal to a squared minus b squared. Okay. So let's jump ahead to some examples of those. And so you see, again, when you have two binomials where the only difference between them is the addition and the subtraction between the terms inside the brackets, then you can just jump right to doing this. So we're going to get x squared minus 9 because we square the first thing and we square the other one and we subtract the two. Square the first thing, square the second thing, and subtract the two. Same thing here. So we've got 2x all squared minus y squared. So when you simplify this, you get 4x squared minus y squared. Now down here, you'll notice that it doesn't quite work out. This kind of looks the same, but at the same time, this one's minus, and this one looks like it's minus as well. But we have this negative there as well. So what I'm going to do is I'm just going to focus in on the second bracket and see if we can make it look like this. So I'm going to just write out x plus 3 here. That's what we want it to look like. But we have to make these two things equal. This one and whatever we have here has to be the same. Well, what would we need to multiply this second bracket by in order to get that one back out? Well, if we multiplied the x by negative 1, we'd get minus x. If we multiplied the 3 by negative 1, we get minus 3. So if we multiply the whole bracket by minus 1, then we're going to get the same value over here. So, or the same expression. So x minus 3 times minus 1 times x plus 3. Just getting away from all my lines here. Now I'm just going to reorganize this a little bit. Put my minus 1 over here. Again, it doesn't matter what order you multiply in. So you can put that first. And now this is in that form we want. And so we end up with minus 1 times x squared minus 9 again. Now I can bring this back in, make it a little bit simpler, get minus x squared plus 9, or if you like, reorder this and get 9 minus x squared. Okay. So there's just a few kind of shortcuts that you can use when you're doing special products.